Okay, good morning and a very good day to everyone. Today, our group will be representing on the topic teaching and assessment issues in mathematics education, with a particular focus on four important mathematical domains, which is measurement, geometry, statistic, and probability. Mathematics education plays a crucial role in developing logical thinking, problem solving, problem solving skills, and analytical abilities among students. However, many students have shown that students often struggle with understanding fundamental mathematical concepts due to misconception and ineffective teaching strategies. According to the Malaysian Ministry of Education, right? Okay. According to Malaysian Ministry of Education, misconception in mathematics remain one of the major reasons for low student achievement in the subjects. Okay, this situation indicates that mathematics teaching cannot rely solely on traditional instruction. Teachers must identify the root cause of misconception and adapt their pedagogical approaches to improve conceptual understanding rather than procedural memorization. Okay, one of the major issues in mathematics teaching is that classroom instruction frequently emphasize procedural knowledge understanding. In many classrooms, students are taught to follow steps or formula in order to obtain correct answer. While this approach may help students perform well in examinations, it often limits their ability to apply mathematical knowledge in real-life situations. Researchers have argued that meaningful learning occurs when students understand the reasoning behind mathematical procedures rather than simply memorizing them. Okay, so the emphasis on procedural learning suggests that assessment practice may also encourage surface learning. Therefore, assessment system must be designed to evaluate conceptual understanding and reasoning skill rather than focusing only on correct answer. Okay, next on the key topics where misconception frequently occur in measurement. Okay, measurement is a fundamental mathematical concept that involves understanding units, quantities, and the relationship between them. Okay. Alright, so however, many students struggle to differentiate between measurement units such as centimeters, meters, and kilometer itself. For example, some students may incorrectly assume that a larger numerical value always indicates a larger measurement without considering the unit involved. This misunderstanding demonstrates that students may not fully grasp the concept of unit conversion. So, this misconception shows that students may be learning measurement as isolated facts rather than as interconnected concepts. Without conceptual understanding, students cannot accurately interpret measurement in real world context. Okay, so another issue related to measurement is the lack of hands on learning experience in the classroom. When teaching measurement, some teachers only rely heavily on textbooks and worksheets instead of allowing their students to interact with real objects. For example, students may solve measurement problems only on paper without even using a ruler or measuring tape. As a result, they might find it difficult to relate mathematical concepts to practical situations. So this highlights the importance of experiential learning in mathematics education. When students are actively involved in measuring objects, they are more likely to develop a deeper understanding on measurement concept. To address this issue, teacher can incorporate innovative teaching strategies such as inquiry-based learning and the use of concrete materials. For instance, students can participate in activities where they measure classroom objects, compare lengths, or estimate distance. Technology can also play an important role by providing interactive simulation that allows students to visualize measurement relationship. Okay, so next we go to Hisham.
Okay, next. Siapa tadi Syam kat itu? Okay, next, the issues is in geometry and statistics. Geometry is another important area in mathematics where students frequently experience misconception. Geometry involves understanding shapes, spatial, relationship, and properties of figure. However, many students struggle to recognize the characteristic of geometric shapes because they tend to rely on visual appearance rather than mathematical properties. For example, students may assume that a square must always appear in a specific orientation. They may fail to recognize the same shape when it is rotated. This misconception demonstrates that students often rely on perceptual reasoning rather than analytical reasoning. Effective geometry instruction should therefore emphasize and defining properties of shapes rather than their visual representations. In another common difficulty in geometry involve understanding three-dimensional shapes. Students often find it challenging to visualize objects such as cubes, prisms, and pyramids because these shapes require spatial reasoning skill. Without sufficient visualization opportunities, students may struggle to understand concepts such as volume and surface area. The challenge of spatial visualization The challenge of spatial visualization indicates that geometry teaching should incorporate visual and tactile learning methods to support students' cognitive development. One effective solution is the use of manipulatives and digital technology in teaching geometry. For instance, teachers can use physical models or building blocks to demonstrate geometric concepts. Digital tools such as GeoGebra can also help students explore geometric relationships dynamically. Through interactive exploration, students can develop deeper understanding and geometric structures and patterns. Technology enhanced learning environments enable students to explore mathematical concepts actively, which support the development of higher order thinking skills. Another domain that presents challenges in mathematics education is statistics. Statistics involve collecting and analyzing and interpreting data. However, many students experience difficulty understanding statistical concepts such as median, and median, and mode. Students may be able to calculate these values but fail to interpret what they represent in real-world context. This issue reflects a gap between procedural competence and conceptual understanding in statistics education. Students must learn to interpret statistical results meaningfully rather than merely performing calculation. Furthermore, students often struggle with interpreting graph and charts such as bar graph, line graph, and pie charts. This difficulty may arise because students are not given sufficient opportunities to analyze real data sets in classroom activities. To improve statistical literacy, students must engage with automatic data and learn how to interpret information critically in real-world situations. Teachers can address these challenges by implementing project-based learning activities. For example, students can conduct surveys within their classroom, collect data, and present their findings using graphs. This approach encourages to active learning and helps students understand the relevance of statistics in everyday life. Project-based learning. Project-based learning promotes deeper understanding because students actively construct knowledge through real-world investigation and collaboration.
Okay, now I will talk about issues in probability, assessment, and conclusion. The final mathematical domain that we will discuss is probability. Probability focuses on predicting the like the likelihood of events. However, students often misunderstand the concept of independent events. For example, some students believe that if a coin lands on head several times consecutively, the probability of obtaining tails in the next toss will increase. This misconception illustrates the common cognitive bias known as the gambler's fallacy, which occurs when individuals incorrectly assume that past outcomes influence future independent events. In reality, each coin toss is an independent event with an equal probability of producing heads or tails. Misunderstandings such as this occur because students often learn probability through formulas without engaging in experimental activities that demonstrate randomness. Probability concepts become clearer when students observe patterns through experimentation, highlighting the importance of experiential learning in mathematics education. Teacher can address this issue by conducting probability experiments in the classroom. For example, students can toss coins, roll dice, or use digital simulations to record outcomes and analyze probability patterns. These activities encourage students to make predictions, test hypotheses, and interpret results. Experimental learning allows students to connect theoretical probability concepts with observable outcomes, thereby strengthening conceptual understanding. In addition to teaching strategies, assessment practice also play a significant role in improving mathematics education. Traditional assessments often focus on writing examinations that evaluate students' ability to produce correct answers. However, such assessment may not accurately measure students' conceptual understanding or problem-solving abilities. This limitation suggests that assessment systems should incorporate multiple evaluation methods in order to capture a broader range of student learning outcomes. Alternative assessment methods such as formative assessment, project-based assessment, and classroom observation can provide valuable insights into students' learning process. These approaches allow teachers to identify misconceptions early and provide immediate feedback to support student learning. Formative assessment is particularly effective because it transforms assessment into a tool for learning rather than merely a tool for evaluation. So, in conclusion, misconceptions in mathematics frequently occur in the areas of measurement, geometry, statistics, and probability. These misconceptions are often caused by teaching approach that prioritize procedural learning and assessment methods that emphasize final answer instead of conceptual understanding. By integrating innovative teaching strategies, technology, hands on activities, and authentic assessment practice, teachers can create more effective mathematics learning environment. Ultimately, improvi- improving teaching and assessment practice will help students develop stronger mathematical reasoning and problem solving skills. Improving mathematics education requires a holistic approach that combines effective pedagogy, meaningful assessment, and continuous professional development for teachers.
Alright, that's all from our group, and thank you, Cik. Thank you, Cik Firdaus. Okay. Macam mana nak ni? Ni cut lah